Alright, rational and polynomial inequalities. So now we've spent a good deal of time on graphing these things so we can make them into inequalities as well. And one way to do that is graphically. And that works really well for polynomials. For example, this one here, if you had to solve that, it would be pretty easy to come up with a sketch for this, because there's a 0 there, there would be a 0 here, there would be a 0 there. Okay, so I can mark them. So I got a 0 at, let's see, 0 here at a -3, 0 at 1, and 0 at 4. That's a square, so this is a double, so it touches, right? That's a single, so cross. That multiplicity is also just 1, so that crosses. And then overall this is an x squared and an x cubed and an x to the 4th with a positive coefficient, so it starts up on both sides. So there we go. It touches here, and then it crosses, and then it comes back. So based on this graph, you can see when is it less than equal to 0. So it's equal to 0 here, so that would be at x -3. It's equal here, and equal there, and in between. So this would be x as an element of the set 1 through 4. And so this inequality solves with x equal to -3 or x is an element of the set 1 through 4. If you remember, inequalities often graph on a number line, so that would look a little like this. At a -3 you would just put a dot, at 1 you put a dot, at 4 you would put a dot, but these two get to be connected, and then that will be it. So that's an easy way to graph it. Now, do you have to graph the polynomial function to solve it? No, you don't. You would find the zeros, okay, and then you just plot them on the number line right away, and then you can use testing points. Okay, and some of you don't like the whole graphing idea because you're not sure about maybe the doubles and the crossing and all that. So we'll do the same one now, but we'll do it just algebraically. So again, it solves very similar. You would find the zeros. So there's a 0. Okay, I don't have to worry about doubles and all that. There's a 0, and there's a 0. So I can put this on a number line. So -3. Let's see, you do have to look at the inequality symbol. It is included. 1 is included. And then probably should put 4 a little further. So 4 is included. And then just test. So in testing literally means you pick some numbers. So for example, what happens at 0? And you just plug it in. So we get 3 squared times a -1 times a -4, and that needs to be less than or equal to 0. So this is at 0. So it's a positive. Well, this one you can actually do. That's 9 times 4, that's 36, and 36 is not less than or equal to 0. Okay, so here I would mark this with like little negatives. So that means I don't get solutions there. Okay, so how about here? What about between 1 and 4? Well, let's try, for example, with 2. What happens at 2? Okay, so, sorry, I forgot to mark this as testing. So again, I'm going to test. I'm going to see what happens at 2. And so now, when I plug in the 2, I get 2 plus 3 squared, 2 minus 1, and 2 minus 4, and that needs to be less than or equal to 0. Now you don't actually have to find the numbers here because you just want to know if it's true. So what I often do here is 2 plus 3 squared, that's a plus, 2 minus 1, that's a plus, and 2 minus 4, that's a negative. So I get a negative here, and that is less than or equal to 0. So here I get answers, and answers means that I would put little pluses there initially because I get solutions that are true. So this is a region with solutions that are true. And then you still have to do it here at 5 and maybe here at a -4. And that's why I said, you know, you don't have to completely figure out what the values are. You just have to know, do I get positives or negatives? So 5 plus 3 squared, that's a plus. 5 minus 1, that's a plus. And 5 minus 4, that's a plus. And 3 pluses, that's false. So I get negatives over here again. And then I'm almost out of room, so I need to check one more. So let's check out a -4. So -4 plus 3 squared, that's still a plus. A -4 minus 1, that's a negative. And a -4 minus 4, that's another negative. And two negatives make a positive, so a positive is not less than equal, so that's false again, so I get negatives again. And then you would finish it by making it, there's your solution region, and then these, and this is one reason to use pencil, you can mark it off. So those are not part of the solutions. And then that's it. Okay? Well, it works the same way with inequalities. You can either graph the inequality and then answer it, or you can do it algebraically. And I'll do that on the next clip. So this one I'm going to split into two. Alright, so look at the next clip for that one. Thanks.